Let's go ahead and do another example of dividing two complex numbers. So in this example, we're going to have 1 plus 3i divided by 1 plus 2i. Now, just like we always do, we're going to first multiply the top and the bottom by the conjugate of the bottom. So the bottom is 1 plus 2i, so its conjugate is 1 minus 2i. So we multiply the top and the bottom by 1 minus 2i. And this is going to give us, on the top, we have the quantity, 1 plus 3i, times the quantity, 1 minus 2i. And on the bottom, we're going to have 1 plus 2i times the quantity, 1 minus 2i. Okay, now let's go ahead and simplify this. So what happens on the bottom? Let's look at that first because it's going to be a little quicker. So on the bottom, we have something in the form a plus bi times a minus bi. Okay, so notice it's 1 plus 2i times 1 minus 2i because we're multiplying a complex number by its conjugate. And we've said this a bunch of times, but we'll point it out again without going through the details because we have covered it before. So a plus bi times a minus bi is just a squared plus b squared. Now in our case, a is 1 and b is 2. So in our case, we're going to have 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. Oops, it's a goofy looking 5. Okay, so on the bottom, we have just 5. Probably need a little more room on the top. Now, what's going to happen on the top? So the top, unfortunately, is a little more complicated. We don't have anything nice that we can do like this. We're just going to have to multiply it out. But we know how to multiply complex numbers. We've covered that before, right? So we're just going to FOIL it. Okay, so coming off to the side here, let's take a look. So we're going to do 1 plus 3i times 1 minus 2i. Okay, so we're just going to FOIL, F-O-I-L, first, outer, inner, last. So first gives us 1 times 1, okay? 1 times 1 is 1, and then outer is going to give us 1 times negative 2i, so that's going to be minus 2i. Inner is going to give us this 3i, this plus 3i times 1, okay, so that's going to give us a plus 3i. And then last is going to give us, or what we're going to have is plus 3i times negative 2i, so that's going to be plus 3i times negative 2i, and that's a little more complicated than these, so that's going to be minus 6i squared. Okay, so plus 3, negative 2, that gives us the minus 6, and then I times I gives us the I squared. Now when we simplify, we have 1 minus 2i plus 3i, that just becomes a plus I, that's nice. Now minus 6i squared, so minus 6 times negative 1. Remember, I squared is negative 1, right? I squared is just negative 1, that's the whole thing with complex numbers. So minus 6i squared means minus 6 times negative 1. Okay, and this is 1 plus I plus 6. Okay, minus 6 times negative 1 means plus 6. So this becomes 7 plus I. Alright, so when we simplify the top, we end up with 7 plus I. Okay. Now we could have kept doing all that over here, but we'd have to keep track of the dividing by 5 over here, and it would just get pretty messy. And there's no reason to keep the 5 in there. We can just ignore it, do this off to the side, and come back to this at the end here. So we're not quite done yet because technically we really should answer this in standard form. This is not quite in standard form because standard form says we have to have a real part plus or minus an imaginary part times I. And we don't exactly have that. We almost do. All we have to do now is split this up into two fractions. So this is going to be 7 over 5 plus 1 over 5 times I. Okay, because here this I by itself, that's really just the same thing as 1 times I. Okay, 1 times I. So what we have is 7 over 5 plus 1 over 5 times I, and that's our answer. So if we have 1 plus 3i and divided by 1 plus 2i, then our final answer here is going to be 7/5 plus 1/5 times I. And that's one more example of dividing complex numbers.